The universe is an expanse that defies human comprehension, a realm where the sheer scale humbles even the most ambitious minds. Estimates suggest there are more stars in the observable universe than grains of sand on all Earth's beaches combined, a staggering figure that pushes the boundaries of our imagination. Yet, despite this abundance, the cosmos is remarkably empty. If we shrank each star to the size of a sand grain, the average distance between them would be about 5 miles, akin to the height of Mount Everest. In real terms, this translates to roughly 4 light-years between stars, a gulf that current human technology can't bridge. NASA's Parker Solar Probe, the fastest spacecraft ever built, would take around 7,000 years to cover that distance to the nearest star, Proxima Centauri. The closest galaxy, Andromeda, lies hundreds of thousands of times farther away. This isolation creates an invisible cage around humanity, confining us to our solar system under the unyielding laws of physics. Dreams of interstellar exploration seem thwarted by these cosmic barriers, as if the universe itself is daring us to try. But where science and engineering falter, imagination thrives. By weaving established physical theories with creative speculation, we can envision a spacecraft capable of propelling humanity to the universe's farthest reaches. What wonders and perils await on such a journey? What lies at the cosmos's edge? Strap in, crew. Liftoff is imminent. At the heart of this thought experiment is our hypothetical spaceship, a marvel born from unfettered creativity rather than earthly constraints. Unlike any vessel humanity has constructed, it accelerates at slightly more than Earth's gravity, about 10 meters per second squared, 1 g, where g is approximately 9.81 meters per second squared. This means every second, the ship's velocity increases by 10 meters per second. We assume it can sustain this indefinitely, impervious to radiation, collisions, or fuel shortages. A bold leap that underscores the narrative's strength in blending education with fantasy. Initially, the ride might feel jarring for unaccustomed passengers, but the 1g acceleration mimics Earth's acceleration builds gradually. In just 2.5 hours, we pass the moon. A day and a half later, Mars recedes in the rearview. After 3 weeks, we exit the solar system at over 40 million miles per hour, 6% of light speed. This dwarfs the Apollo 11 missions, but hasn't yet invoked Einstein's special relativity in full force. As we venture toward Alpha Centauri, the nearest star system at 4.4 light-years, the sun dims to a faint point, while our destination's light grows brighter. The first year passes uneventfully, save for the ship's relentless speed gain. Real-time chats with Earth become impossible due to signal delays, but delayed news feeds keep us connected to home. Politics, culture, sports, and scientific breakthroughs arrive with increasing lag. 15 months in, we celebrate crossing 1 light-year, a quarter of the way to our goal in distance, but a third in time, thanks to accumulating velocity. A key milestone, the Lorentz factor, surpasses 2. This factor, Gamma equals 1 over the square root of 1 minus v squared over c squared, where v is velocity and c is light speed, quantifies space-time warping. It leads to relativity's hallmarks: length contraction and time dilation. For Earth observers, our trip spans 15 months. Aboard, time feels shorter. Now, at 87% light speed, the ship seems poised to exceed c in 45 days from an inertial frame. But Einstein's rigorously tested theory forbids this for massive objects. All observers see speeds capped at c. Analogize it to chasing a car. If it's going 60 miles per hour and you're at 50, it recedes at 10 miles per hour. But light always recedes at c, regardless of your speed, forcing time and space to adjust via Lorentz effects. Earth viewers see our acceleration dwindle towards zero as we near c, but we feel constant 1g. Subjectively, we surpass light speed long ago, with the sun's light fading unnaturally fast. This detachment from external spacetime highlights the narrative's educational prowess, demystifying relativity through experiential storytelling. Yet, infinite acceleration demands infinite energy, a controversial oversight. Deceleration at -1g is needed for arrival, mirroring the outbound phase. Reaching Alpha Centauri takes 3.5 ship years, but 6 Earth years. A brief exploration, then return. Total 7 ship years versus 12 on Earth. Not bad for conquering the nearest star. This part of the journey exemplifies the content's best aspects. Accessible science, wrapped in adventure. It sparks wonder about our place in the cosmos, using analogies to bridge abstract concepts. However, controversies lurk in the assumptions of boundless tech, setting the stage for deeper scrutiny. Imagine hurtling through the void at speeds that warp reality itself. Time stretching like taffy, distances shrinking, and the familiar laws of the universe bending in ways that challenge everything we thought we knew. This is the thrilling core of our hypothetical cosmic odyssey, where the original content dives headfirst into Einstein's special relativity, transforming a simple spaceship trip into a mind-bending exploration of time dilation and velocity's illusions. It's here that the narrative shines brightest, turning dense physics into an adrenaline-fueled adventure. But it also stumbles into controversy by flirting with ideas that skirt the edges of scientific accuracy. Let's strap back in and dissect this phase, from the Lorentz factor's magic to the thorny assumptions about tech that could make or break our interstellar dreams. As our imaginary vessel surges onward, this story ramps up the drama with milestones that feel like plot twists in a sci-fi blockbuster. We've left Alpha Centauri behind, opting not to stop, but to push further, dividing the journey into acceleration outbound, deceleration, then the reverse for the return. This setup cleverly illustrates how constant 1g thrust could theoretically compress epic distances into manageable ship time. Picture this. To escape the local interstellar cloud, a 30 light-year round trip, we endure 33.4 years aboard. But back on Earth, your kids are pushing 70, leading to those poignant, movie-like reunions where generations have aged while you've barely grayed. It's a masterful hook, using personal stakes to make relativity relatable. Who hasn't wondered about outliving their world? The Lorentz factor takes center stage here, evolving from a mere equation into a cosmic game-changer. As velocity approaches light speed, gamma skyrockets, causing time to dilate. From the crew's view, everything's normal. We keep accelerating at 1G, subjectively blasting past C. But Earth observers, they see our speed asymptote towards C, never crossing it, with our clocks ticking slower. The content nails this duality with vivid analogies, like chasing a light beam that always outpaces you, no matter how fast you go. It's educational gold, demystifying why faster-than-light travel is forbidden for anything with mass. It would require infinite energy, and causality could unravel, allowing paradoxes like messaging your past self. Yet, this is where controversy ignites. The narrative boldly claims the ship has already surpassed the speed of light from our onboard perspective. A seductive idea rooted in proper acceleration, but one that misleads. In reality, while we feel endless speed-up, no frame of reference ever measures us exceeding C. It's a relativistic illusion. Critics might argue this blurs the line between subjective experience and objective physics, potentially confusing readers into thinking FTL is possible with clever engineering. Einstein's theory, battle-tested for over a century, stands firm. Massive objects can't hit or beat C. By glossing over this, the piece risks promoting pseudoscience, even if it's framed as imagination. Pushing boundaries further, we venture to the local bubble's edge, a 300 light-year jaunt. That's 22 ship years, but 600 Earth years. Now, the stakes skyrocket, returning to a world where your mission is ancient history, perhaps forgotten amid centuries of change. The story amps the engagement with sensory details, peering out the window to see cosmic microwave background radiation shift to visible red as gamma hits 650. It's a stroke of genius, visualizing abstract effects like blue shifting radiation, making the cosmos feel alive and tangible. But acceleration isn't free. And here's another flashpoint. The assumption of unlimited energy and flawless shielding. Achieving constant 1G demands exponentially more fuel as speed climbs. Think antimatter drives or exotic matter, none of which exist today. The original ignores entropy, heat dissipation, or particle collisions at relativistic speeds, where even sparse interstellar gas becomes a deadly barrage. NASA's real probes, like Voyager, crawl at 0.006% C. Scaling to near C would require godlike tech. This optimism borders on controversy, echoing debates in sci-fi communities about hard versus soft science. Does hand-waving feasibility inspire or deceive? Venturing galactic scale, a 100,000 light-year round trip to the Milky Way's rim takes 41 ship years, leaving us in our 60s upon return. But Earth? Millions of years older. The narrative pivots to futurism, speculating on humanity's evolution. Orbital habitats like spinning cylinders for artificial gravity, lunar caves at cozy 17 degrees Celsius, or 3D printed moon bases from regolith. It nods to NASA's Artemis program, Artemis 1's 2022 success, Artemis 2's planned 2024 crewed orbit, delayed to 2025 per updates, and Artemis 3's 2026 lunar landing goal. These tie-ins ground the fantasy in reality, showcasing the content's strength in bridging today's tech with tomorrow's possibilities. Controversially, though, these projections treat models as gospel. Earth's million-year fate, continents reshaped, sun 10% brighter, eroding atmospheres, is plausible but uncertain. Variables like human intervention or unforeseen events could alter outcomes. Similarly, anti-aging tech from Mayo Clinic's mouse studies, extending life 35% by zapping senescent cells, is extrapolated wildly for cosmic voyages, ignoring human trials' hurdles, ethics, or side effects. It's engaging speculation, but skeptics might call it overhyped, fueling debates on transhumanism's promises versus perils. In essence, this segment captivates by humanizing relativity's weirdness, turning equations into emotional journeys while sparking controversy through its bold leaps. It reminds us that exploration's thrill lies in the what if, even as physics anchors us. But as we approach the universe's fringes, deeper questions loom. What awaits in the void? And is the cost worth it? You've blasted past the Milky Way's shimmering arms, your ship, a lone comet, streaking through the infinite black. But as the original narrative propels us toward the universe's edge, it unleashes a torrent of speculation on humanity's future, orbital utopias, immortal explorers, and the chilling grip of cosmic expansion. This finale crackles with optimism, painting a canvas of technological triumphs. Yet it stirs controversy by betting big on unproven leaps. Buckle up. We're diving into the what-ifs that could redefine existence, all while grappling with the void's whisper. Is any of it worth the chase? With longevity tech in our arsenal, the story catapults us to the Virgo cluster, millions of light-years distant. A 67-year ship odyssey where Lorentz soars to 250 million. Returning, Earth's unrecognizable, continents adrift, CO2 plummeted, photosynthesis faltering, the sun's glare 10% fiercer, scorching life away. It's a haunting vision, amplified by the content's flair for drama, turning science into a cautionary epic. But here's the hook. Anti-aging breakthroughs make it feasible. Drawing from Mayo Clinic's cutting-edge work, the narrative extrapolates mouse trials where clearing senescent cells, those zombie-like culprits behind heart failure, arthritis, Alzheimer's, and cancer, boosted lifespan by 35%. Using proteins like caspase via periodic injections, researchers zapped these cells, leaving rodents spry into old age. Fast forward to 2025 updates. Mayo's labs are buzzing with progress. A February study linked senescent biomarkers to mobility issues in seniors, paving the way for behavioral tweaks and drugs to slash cell burden. By September, their SkinSpan framework targeted skin aging, hinting at broader anti-aging therapies. while human trials lag, focusing on 60 to 70% cell clearance without gut or liver risks. These strides fuel the tale's optimism. Imagine crew members, ageless and resilient, outlasting eons. Yet, controversy brews. Is this ethical? Overpopulation, inequality in access, or unintended mutations could doom us faster than entropy. The piece glosses over these, embracing a transhumanist dream that critics decry as hubris. Meanwhile, Earth's survivors thrive in engineered havens. The content envisions massive orbital stations, spherical, toroidal, or cylindrical behemoths housing up to 1 million souls, spinning for gravity, farming under solar windows, shielded by polyethylene or magnetic fields. Lunar caves, a steady 17 degrees Celsius sanctuary, become bustling colonies powered by compact nuclear fuel cells. From Bangor University, NASA's 3D printing tech molds homes from moon dust, echoing real strides. Tying into today's headlines, Artemis missions anchor this vision. Artemis 1 nailed its 2022 lunar loop, but delays hit hard. As of October 2025, Artemis 2's crewed flyby eyes February 2026, while Artemis 3's landing slicks to mid-2027 at earliest. Shakeups from leadership changes underscore the grind. These pit stops fuel Mars dreams, with SpaceX's colonies and NASA's Texas Sims ongoing since 2023, testing red planet life. This futurism dazzles, blending hard facts with bold extrapolation, inspiring awe at human ingenuity. But it's contentious. Assuming flawless tech ignores climate crises or AI upheavals that could halt progress. And the anthropocentric lens, it romanticizes conquest without reckoning environmental tolls or indigenous space ethics. Yet the true thrill and thorn is the philosophical payoff. Dark energy's accelerating sprawl caps our reach at 8.3 billion light-years for round trips. Cross it, and you're exiled forever. One-way jaunts turn the ship into a time machine, fast-forwarding Earth to 10 to the power 41 years. Protons decayed, reality unraveled. What's the point amid inevitable nothingness? The narrative posits exploration as humanity's spark, defying the flat Earth myths of yore. It's a rallying cry. Even if we never grasp the cosmos's end, the quest propels civilization. Controversial? Absolutely. Some see it as futile escapism. But in this gripping yarn, it ignites hope. Our ambitions, not the stars, define eternity.